All right, so this example, they ask us to evaluate the tangent of that. So just to review here, these are ratios because you take arc sines and arc cosines of ratios. And then when you take an arc sine of a ratio, that's going to give you an angle. So I'm going to call theta the arc sine or inverse sine of 3/5. And I'm going to call phi the arc cosine of -5/13. So if I do this substitution, then this simply becomes the tangent of theta minus phi. Now I don't know what theta minus phi is. I can't find these angles in exact form. But what I can do is I can use my sum and difference formulas. Here's the tangent ones, to write that sum or difference as tangents of the individual angles. So remember, it's tangent plus tangent, 1 minus the product if you have a plus. So basically the numerator's got the same sign and the denominator's got the opposite sign. So I can write this as the tangent of theta minus the tangent of phi over 1 plus the tangent theta times the tangent of phi. So I can evaluate this as long as I can figure out what the tangents of the individual angles are. So to do that, let's draw a picture. Arc sine is going to give me an angle in these two quadrants. The sine ratio is positive, so let's draw that triangle in the first quadrant. That's where the sine is positive out of those two. This is my angle theta. Sine is 3/5, opposite over hypotenuse, so this is going to be a 3, 4, 5 triangle, or feel free to use the Pythagorean theorem. Our cosine is going to give me an angle in these two quadrants. My ratio is negative. All students take calculus, so negative ratio for the cosine is going to be over here. Cosine is 5/13. I make that a -5 and a +13. This is also a Pythagorean triplet. It's a little not quite as known as the 3, 4, 5. It's the 5, 12, 13. If you don't remember that, that's fine. Use your calculator. Just a quick FYI, this is the angle phi. This is the angle phi bar. Reference angle of phi. Okay? Not that it matters. All right, so now I can evaluate these things. So the tangent of theta, look at this triangle here. Tangent is 3/4 positive, so 3/4 minus. Tangent of phi is this triangle. That's going to be negative 12/15. Sorry, 12/5, my bad. 1 plus their product, 3/4 times negative 12/5. So change the signs here, subtract that a positive. I'm going to multiply this by 5/5. Multiply this by 4/4. Here I'm going to cancel the 4 and the 12. So that gives me, I'm going to multiply this by 5/5. So I have 15 plus 48/20 all over 5 minus 9/5. That is 63/20 multiplied by the reciprocal, 5/-4. Take a 5 out of here, 5 out of there. That would be -63/16. Okay. All right, I had problems checking the other one in the calculator because there were some details that caused the signs to be messed up. By the way, that was, it just happens with those ones. But this one should actually work because these are all functions. So there's a function in the calculator I've never really showed you. It's pretty neat. If you hold the vars key for 3 seconds, and then you just say the equation, what is the sine of, sorry, cancel. Hold this button. What is the tangent of the arc sine of 3/5 minus the arc cosine of -12/5. And then you hit the vars key again, it'll recognize that voice chat. So then if you do that and you just hit enter, you get -63/16. So that's a pretty cool feature, and it does check out. Example 2. Express the following in a form without trig functions. So I have the cosine of the inverse sine of 2x plus the inverse cosine of 3y. So these all work out the same way. This has just got variables. So this has got, these are ratios. So let's let alpha equal the inverse sine of 2x over 1. And beta equal the inverse cosine of 3y over 1. So I need to take the cosine of, this is just alpha, minus this is just beta. So cosine, if you remember the formula, it is cosine, cosine, sine, sine, change the sign. Cosine, cosine, sine, sine, change the sign. More triangles, more angles. Inverse sine is going to give me an angle in these two quadrants. Here I don't know if the ratio is positive or negative. It depends on x. We're not going to give you those hard ones where you got to do all that stuff at the end and figure out if you got absolute values and all that. So just draw it in one of the two quadrants, and it really doesn't matter on this one. Sine is 2x over 1. Use the Pythagorean theorem to find the unknown side. 4x squared plus x y a plus a squared equals 1 squared. A squared equals 1 minus 4x squared, plus or minus the square root of that. I'm going to take the positive one because it's positive. 1 minus 4x squared. Some of you guys can do those Pythagorean theorems in your head. Others are going to need to write out a little bit more, but you do what you need to do. Inverse cosine, these two quadrants, again, don't worry about it. Just put it in the first quadrant, not a big deal. Cosine is 3y over 1. This is going to be the square root of 1 minus 9y squared. Again, do the Pythagorean theorem if you need to. All right, we're ready to get our answer. This is the, so I just, use your alphas. This is angle alpha. This is angle beta. You just, take the cosines and sines from the proper triangle. Cosine of alpha is square root of 1 minus 4x squared all over 1 times cosine of beta is 3y over 1 plus sine of alpha is 2x over 1 times sine of beta is square root of 1 minus 9y squared all over 1. So this is 3y square root of 1 minus 4x squared plus 2x square root of 1 minus 9y squared. And that is your answer. Okay. So what's, I don't know, I wish I could show it to you maybe a little more gracefully somehow, but maybe I'll pause the video and try to figure out a clever way to do it. But basically what I'm telling you is this function is exactly the same. This expression is exactly the same as this expression. This one's got trig in it, this one does not. All right, so I was trying to find a clever way to prove this equation or to show you that it checked the solution. And I realized when I checked my answer that I made a mistake here. I'm sorry if I did this. I didn't want to redo the whole video, but this is a plus. And I put a minus right there. It's supposed to be alpha plus beta. So I'm sorry, that probably confused you. This should be a plus. That means cosine, cosine, sine, sine, change the sign. That should be a minus, meaning these should be minuses. I'm sorry, it happens. People make mistakes. But that's why you check your answers. And so here, my attempt to show you how to check this, You kind of need a 3D grapher if you want to check a variable, an equation, an expression with two variables. So I put this equation into my fancy 3D grapher. You just type it in exactly like you see it. It's kind of nice. I say z equals, and it gives me this surface. So it's kind of weird, kind of cool. It's curvy, right? And then if you remember what that looks like, when I graph this other expression, z equals this, I should get the exact same thing. I should get the exact same curve. That tells me that that's the same for all combinations of x and y. So I'm just gonna, so on this one program here, if you just think the equation, it automatically puts it in. So I'm just thinking of the equation, boom, puts it in. It reads your mind. It's pretty awesome. So this is 3y square root. It's exactly like you've seen it. So you saw what it looked like before. It's going to just graph right over top of it. Now it's purple because it graphed that surface right over top of that other surface. And as you can see, for every combination of x and y, you get the exact same values. So that tells us that those two expressions are the same exactly for all values of x and y. And one more video to get to the end. I'm sorry for the length.